Okay, assume that in humans the allele for brown eyes is capital B and it's dominant to the allele for blue eyes. Okay, got enough to do a legend? Let's do step one, legend. So capital B, when it's dominant, I don't care what the other allele is, it's going to be brown. And for blue eyes, this is how it works. What you do is you take the small case letter for the dominant trait. So capital B is the dominant. We're going to give two little b's then for blue. That's generally how it works for the recessive trait. Okay, so you take the small case letter of the dominant trait. In this case, brown is the dominant, so it gets little b's. Now, I know blue starts with a B anyways, but it won't always be like that. So that's generally how you work it out for the legend there. So there's your legend. Now, it says, what is the probability that the first child of two heterozygous brown-eyed parents will be blue eyes? So they want to know this. They want to know, with these two parents, two heterozygous brown, what is the probability of having a blue-eyed child? So we underline the parents. Let's show us the genotypes because they're both heterozygous brown. Capital B, little b. Hetero meaning different. The other parent's going to be exactly the same thing. Now we know before we even go any further that with these type of patterns in a monohybrid, when both parents are heterozygous, you would expect a 3-to-1 ratio. 3 being dominant, 1 being blue. But let's kind of work this question out with our step 3, which is a Punnett square. Okay, step 3, Punnett square. Isolate these gametes. It doesn't say which one is the male or female. In this case, it doesn't matter because they both have the same genotypes. So we're going to isolate those into gametes. Capital B, little b. Now they want to know the probability of having a blue-eyed child. So bring them in, capital B, it's going to be brown. And after a while, you're going to get really fast with these ones here. Brown, capital B, little b. Again, we're simulating fertilization. Brown, and again, as we expected, because both parents are heterozygous, here is our lonely one blue-eyed child. That's the only one that's different. So out of the boxes, 4 boxes, 1 out of 4 is going to be blue. They want us to put it into a whole percentage. Okay, so whole percentage, if we have the decimal, decimal 0.25 are going to be blue. If we want it in percentage, we multiply this by 100 or simply just move the decimal over 2 places. And we end up with 25% chance of having a child with blue eyes with those 2 parents. Okay, thanks. Any issues, give me an email. Thanks, guys.